Hi, this is Steve Hoye. I'd like to describe a little bit about the start-stop algorithm that's associated with the auto casting here in the template. Notice that I've selected a group of wells. It looks like there's 107 wells marked, and I have just completed an auto cast run using Markov chain Monte Carlo. And the results then are ready for us to kind of look through. And we'll talk in more detail as we isolate some of these wells. You can see I can come over here to the left. If we just work our way through these well names here, they are sorted alphabetically. You can see this is the result of the Barracuda well. Let's move ourselves on down to this Bearcat 505 well, which is interesting from the standpoint of the start-stop algorithm. To describe what's going on, you can see this elapsed years chart on the bottom. I'll enlarge this so you can get a big look at it here. But what it's looking at is this curve in green is showing us how the start-stop algorithm is sensing changes in production and in more detail, segments, how to separate segments of this production curve. And you'll notice that there's a big drop in this curve, looking at elapsed years here, somewhere between 1 and 2 years. So if we go back and compare this analysis, you can see that the reason why this curve deflects like this is because of the change in production from this part of the curve. And now there's a drop from over 100 barrels a day to less than 60 barrels a day at this point. And that it appears that the decline curve, it continues in a pretty continuous way. So the start-stop algorithm has been detected. It is detected on the green here, this drop. Now notice that the threshold, if we look at the parameters for the AutoCast model, you'll see that for the oil column here, the segment threshold low is set at minus 1.5 units. You can see that's where this green stippled line is showing the boundary. Because of that, and because the fact that this inflection has not gone below this lower threshold, there was no independent or new curve started as a result of this drop, okay? Let's say that we do believe this is that we should be more sensitive to this sort of a change, and that this is in fact a phase of decline that we want to model by itself. Then we can adjust this parameter, and by looking at this chart, we can see that if we were to set this lower threshold at 1, this would actually trigger the AutoCast start-stop algorithm to start a new curve at this production point. All right. Now, the argument for that, if you look at this decline curve, you can see that because it's trying to fit this curve and this curve, the decline appears to be too steep. And in fact, the farther you get in time on this production curve, the bigger the gap between the forecast and the actual production data. So this is going to result, if we leave this the way it is, it's going to result in a very pessimistic, a too pessimistic estimate, EUR estimate for forecasting. So let's go ahead and change this parameter, the one I've described as the lower threshold for oil here, and let's make it 1.0. And then what I'm going to do is I'm going to come up over here on the append replace, and let's append a new AutoCast of this well by itself to the data set. And then we can compare the new AutoCast outcome with the old AutoCast outcome. So we'll wait for a second. This will be a little slow because of the video. But if we cut out the middle part of this here, we can see the results in a second. Notice as well that the gas curve is a good fit. There's really nothing that we would change about this fit at all. It's simply the oil curve that looks interesting from the standpoint of having some sort of a gap here. All right, the AutoCast is completed, and if we look now, we can see that there are 2 of these wells, these 1505 wells, that are a part of our AutoCast. You can see this is the old version, and we can tell that by the timestamp over here at 1412 is our original run. You can see the curve we saw a minute ago. And then if you look, you can see identically the same UWI and well name with a timestamp that's several minutes later here, okay? This is 1438.24. This is the new result. If you look carefully, you can see now that the AutoCast algorithm, the start-stop algorithm, because we brought the floor up on the minimum threshold for oil on this start-stop, you can see now that the curve that's being fit is actually fitting this data, and it's fitting it very impressively. So we're going to get a higher EUR on this particular fit, and you can see that, I mean, the fit's so good that you have to look carefully to see the line kind of peeking out from behind the production records here. So that's a good example, real life example of how you can tune this start-stop algorithm to get a sense of what's going on. One other item for your consideration, if we look at all these, you can kind of see a cluster of all of the start-stop curves for all of the 100 plus wells that we just autocast previously. And you'll notice that if you cross compare the green, the oil, versus the red, you'll see that there's much more volatility in the red. And so there'll be a much higher tendency for you to detect gas outliers, right, and new segments in the gas curve than you are with the oil curve. So those are some observations that can be made, but in specifically just the way we demonstrated, it is useful to be able to look at some of these wells and look at some of the changes in the production here and tune the thresholds at the top and bottom so that they reflect the data set and the behavior of the data set in a way that will cause the start-stop algorithm to give you the best results and the best automation for predicting what the ultimate recoveries are going to be from these wells. So that will finish this particular video on the start-stop. Thank you.